Well, for the past few lectures, we've been exploring the world of numbers and quantity and looking at the hidden structure both within the numbers and reflections within our own everyday world. Well, now we're about to embark on the next major chapter in this course, which is the visual world of geometry, which, believe it or not, parallels the enticement and the intrigue of numbers. And we'll begin this journey, in fact, with a look at aesthetics, our own tastes, and wonder if, in fact, aesthetics can somehow be connected with mathematical thinking. In this lecture, we'll see that, in fact, there are rich connections if we open our minds to explore them. John Keats once wrote, "What the imagination seizes as beauty must be truth, whether it existed before or not." In this lecture, I want us to actually consider beauty as a mathematical possibility. In particular, I want to begin with the following strange question. What do you think of when you think of the sexiest rectangle? Well, what is a sexy rectangle? Well, what I mean by that is the rectangle that you envision in your mind's eye when you close your eyes and think of a rectangle and the ideal proportions. Probably wouldn't be very, very, very long and not very high. Probably wouldn't be very square-like. It probably would be something in between. In fact, here are 4 possibilities I want you to look at. Now look at these 4 rectangles and ask yourself which rectangle captures the spirit of rectangleness in my eye. If I were to close my eyes and think of a rectangle, which of these 4 comes closest to that rectangle? Well, you have your guess. And it turns out that many people like the second rectangle from the left. The second rectangle from the left seems to draw the attention of many, many people. Now, I must tell you that if we actually did an election, we might have another runoff situation and we might have to go back to Florida and Dade County and it might be a mess because it's not absolutely clear-cut. But certainly a plurality of people tend to like that second rectangle. Well, that second rectangle actually is called the golden rectangle. Well, golden rectangle might conjure up images from our previous lecture of the golden ratio. And in fact, there's good reason for that. For a rectangle to be a golden rectangle, the very definition of that is somehow comparing the length of the base to the length of the height. And in particular, we define a rectangle to be a golden rectangle if you take the length of the base and divide by the length of the height. That quotient, that ratio, will be the golden ratio. That special number 1 plus the square root of 5, all divided by 2, which in decimal form is 1.618033898, and so on, goes on. You can plug it in a calculator. That number, which happens to be my favorite number. We're going to see it again. Coincidence? I think not. I like the number, and it turns out it appears throughout the dawn and from the dawn of humanity all the way through humanity's history. So in fact, maybe humanity finds this number to be interesting. Well, the golden rectangle, and here I happen to actually have one for you to see, the proportions of the base to the height of this, in fact, conform to the golden ratio, is a very attractive rectangle. And we've actually seen these things. In fact, you see them all the time at work or at home if you're doing hobbies. If you look at the dimensions of an index card, you will see that they actually are very close. If you take the base to the height, closely conforms to the golden ratio. Surprising? Well, no, because what are the dimensions of this? You know what the dimensions of an index card are. They're 3 by 5. And notice that 3 and 5 are consecutive Fibonacci numbers. So certainly that ratio must be close to the golden ratio, since we've already seen in the previous lecture that as you go down and look at the quotients of consecutive Fibonacci numbers, they do approach this special golden ratio. So this is a very attractive rectangle. And in fact, you may say that, gee, is that coincidence? Well, I would argue not. I think that Madison Avenue knows how allured we are to these and how attractive it is, and that's why we keep buying them. Do you notice that you keep buying these index cards? The reason why you buy them, maybe it's not because of their utility, but maybe because you're drawn to the beautiful proportions of that rectangle. Well, okay, maybe you actually use them. Okay, anyway. Well, There are a lot of examples of the golden rectangle outside of the humorous possibility of looking at the 3x5 index card. And I want us to take a look at some of the examples of the golden rectangle all throughout the art and architectural history of humanity. And let's start, in fact, way back with the ancient Greeks. Now, if you take a look at this image, you, of course, immediately recognize it to be the Parthenon. Now, you might say, oh, okay, Ed, so if I draw a rectangle, from that horizontal line that we see on top down to the bottom and so forth, and it sweeps out a rectangle, that is a golden rectangle, I might hear you wonder. Well, it turns out the answer is no, it's not. Well, because this thing is in ruins. They sort of let it run down and go downhill, and maybe it should be under new management or something. But at one time, it was very fancy, and in particular, it had a roof. How decadent. Now, if you imagine extrapolating that roof line back in and take a look at with the roof line in, then you can draw in a perfect golden rectangle, and you can see how beautifully it conforms to the Parthenon, which leads us to wonder whether, in fact, that was intentional or unintentional or just random. But there you see an example of an image that very closely conforms with the golden rectangle. And we'll come back to this issue of whether it's there or not, in fact, in a few minutes. We do not know if the Greeks deliberately allowed the golden rectangle to inform its art and architecture, or whether it's coincidence, or whether maybe it just happens to be random, and that, in fact, since we can't measure things with sort of infinite precision, it's close, but not exactly a golden rectangle. Well, no one does know, and you can have your own opinion, but it would seem certainly to be more romantic to think that, in fact, maybe they did this subconsciously, where they just picked a ratio of proportions that seemed particularly attractive, and that attractive one seems to conform to the golden rectangle. But for sure, at this point, we do not know the answer whether it was deliberate or not.
These same golden proportions are also found in their sculpture. In the centuries that followed, the golden rectangle dominated the idea of beauty in architecture throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world. Modern painters have rediscovered the magic of these proportions.
If we move ahead a little bit in human history, move to the Renaissance, Leonardo da Vinci definitely was conscious of the golden rectangle and the golden ratio. And in fact, as an example, we should take a look here at the unfinished portrait of St. Jerome. Now, here what we see is a figure in St. Jerome, and he is sort of sitting down, and his arm is extended, his right arm is extended. But if you were to draw a perfect golden rectangle around the figure itself, what you see is that it beautifully conforms with everything, how the head is tilted down, the very bottom of the toe, and the right-hand edge where the, I guess that's the elbow on the left arm is. You can see it conforms quite nicely. And so maybe, in fact, what we're seeing here is a perfect golden rectangle. Well, deliberate or otherwise, we don't know for sure if he deliberately tried to capture that, or if that rectangular shape just seemed to be attractive to him and he was trying to capture it. It is known, by the way, that Leonardo did know about the golden ratio and the golden rectangle, because he actually illustrated a book on the subject, and the book's title was De Divine Proportione, which actually means the divine proportion, which is another word that we use sometimes for the golden ratio. So he certainly knew about these objects, and in fact there's a famous illustration where you can see various features that are trying to capture part of those relations. If we move further through the art history, we come to the Impressionism era in France. And here, of course, the artists and the scientists were having a very exciting moment in history where people were coming together and sharing and exploring ideas. Georges Seurat is a wonderful example of an artist who really embraced these mathematical ideas and tried to incorporate these concepts deliberately in his works. And in fact, it is said that Seurat actually attacked every canvas with the golden rectangle. Very intentional. Here in his painting La Parade, we in fact see many golden rectangles. In fact, you can see glowing 3 different golden rectangles in the work, very deliberately placed. And in fact, they're actually lengths where if you take the actual length and divide one by the other, you actually will get the perfect golden ratio. In particular, if you take the length that you see right there and divide it by this length, then in fact you have the ratio, which is the perfect golden ratio. And similarly, if you take that length and divide it by this length, you have another example of that. If we move to Expressionism and Modernism, Mondrian is a wonderful example of someone who really took this idea to extremes. And in his works, he apparently tried to, as he described it, consider the destruction of volume, the idea of taking space and cutting it up. And here in his work, Place de la Concorde, we see many deliberate golden rectangles. You can see a golden rectangle here, or here, and also here. There are 3 golden rectangles. And again, very deliberate. Someone said, "Oh my God!" I looked at his work and said, "Oh my God, there are all these lines." And he looked at the work and said, "I don't see any lines at all. All I see, in fact, are the space around them," which is interesting. And those are where we see golden rectangles. If we return to architecture but move forward a bit, the French architect Le Corbusier is an architect who actually believes that human life is actually soothed by mathematical ideas rather than pained by them, as so many people in society believe. And so he actually tried to incorporate the golden rectangle in his works. Here we're looking at a drawing of a French villa that he designed many years ago. And you can see that if you draw a rectangle around the villa all the way up to the very top of the roof, you can see the roof extends in the chimney all the way down to the bottom. That's a perfect golden rectangle, and it's a rectangle that actually, in fact, was done deliberately. So deliberately placed there to try to make that environment more aesthetically appealing and interesting. Okay, so if this were one of these infomercials, this might be the time where I'd say, okay, well now I know you're sold. How do I order one? Where's the 900 or 800 number to call to actually own my own golden rectangle? Well, of course, this is actually a class on great thinking and great mathematics, so there will be no 800 number. However, the question of how do you actually construct, how do you actually mathematically build a golden rectangle is a question that's worth asking, and I'd like us to consider. In fact, you can actually build one of these using the techniques of the ancient Greeks, where they used simply a straight edge and a compass to actually make geometric constructions. So I want to actually build you the golden rectangle and give you a method for building your own golden rectangle if you want to build one. And this is going to be a perfect golden rectangle.